Okay, question related to moles. Chemists use the concept of the mole to calculate amount of chemicals involved in a reaction. Define a mole. So first thing, definition of the mole. So what is the definition of mole? It is amount of substance which contain Avogadro's number of the particle, contain 6 exponent 23 particles. So that amount which contains 6 exponent 23 or Avogadro's number, we call that as mole of a substance. That's the definition of the mole. Then in the next question, 3 gram of magnesium was added to 12 gram of ethanoic acid. The mass of 1 mole means the molecular mass of magnesium is 24 and mass of 1 mole of ethanoic acid is 60. Which one, magnesium or ethanoic acid, is in excess? And you must show your reasoning. So what you can do, if the masses are given, like you have 3 gram, uh, you have 3 gram of magnesium and you have 12 gram of ethanoic acid. So first, what you will do, you can simply find the moles of magnesium. How many moles of magnesium are there in the question? So we have the no, from the equation it is 1, but how many moles are there in 3 grams of magnesium? So we have 3 gram of magnesium. So how many moles of magnesium will be there? So moles of magnesium will be mass in gram divided by molar mass or mass of 1 mole, atomic mass.
3 gram divided by 24.
So 3 divided by 24 will get the moles of magnesium. So this will be 3 by 24. What's the answer for 3 by 24? 1 by 8, which is 0.125. And what will be the moles of ethanoic acid? That is also mass in gram divided by molecular mass because it's a molecule. So mass in gram is 12. The mass in gram is 12 divided by molecular mass is how much? For mass of 1 mole means molecular mass 60. So 12 divided by 60, it will be 1 over 5, which is equals to 0.2. 1 over 5 will be there, or 0.2. Now we want to find which one is in excess. Excess means more than enough. So what is the simplest ratio between magnesium and ethanoic acid? So simplest ratio between them from the equation, magnesium and ethanoic acid is 1:2. That's the simplest ratio. Like if you have 1 mole of magnesium, we need 2 moles of ethanoic acid. So if we have 0.125 moles of magnesium, how many moles of ethanoic acid we need? So if 1:2 is the ratio, if we have 0.125 moles of magnesium, how many moles of it? 1:2 is the ratio. If 0.125 moles of magnesium are there, how many moles of ethanoic acid will be there? 0.25. So when you multiply, you will get 0.25. So for a reaction, for a complete reaction, how many moles you should have for ethanoic acid? 0.25. But how many moles you have?
0.2.
0.2. So you have less than what you need for a complete reaction. So it means ethanoic acid is a limiting and magnesium is in excess. Excess means more than enough, because the ratio between them is 1:2. So 1:2 is the ratio. If 0.125 grams or moles of magnesium are there, Then you should
But the
have,
ratio, the
yes,
ratio is from the equation, right? The
ratio is
ratio.
always from equation, yes.
Yeah.
So 1:2 is the ratio from the equation. So this is how many moles we need. We need 0.25 moles of ethanoic acid for a complete reaction, but we have only 0.25, zero point 0.2 moles. We need 0.25, but we have only 0.2 mole. So it shows ethanoic acid is limiting, or we can say magnesium is in excess. Excess means magnesium is more than enough. So if the one reagent is limiting, then the other will be in excess. Then how many moles of hydrogen were formed? So how to get the moles of hydrogen? We always take a limiting reagent to get the moles of product, because a limiting reagent is the one which used up completely. So we always use a limiting reagent to get the moles or the amount of the product. So in the question, we need moles of hydrogen. You can see nothing is given related to hydrogen, but how we can find moles of hydrogen? We can use a ratio.
Ratio.
So which ratio we'll use? Ethanoic acid and hydrogen. Why I'm taking ethanoic acid? Because ethanoic acid is a limiting reagent. Limiting reagent means it is the one which used up completely. So that will decide the product. The excess reagent is left once the reaction finish. So what is the ratio between ethanoic acid and
1 to 1.
hydrogen? Ethanoic acid, 2 moles.
Yeah, 2 to 1.
And for hydrogen, how many moles are there? 1. So ratio between them is 2:1. But how many moles of ethanoic acid are there in the question which we have? We have 0.2. So how many moles of hydrogen will be there? X. Because this 0.25 is the one which we need. This is not what we have. We have only 0.25, zero point 0.2 moles. So 2:1 is the ratio. If we have 0.2, then X moles will be there. Cross multiply. So X will be 0.2 divided by
0.1.
2. That's equal to 0.1 mole. And it's of 1 mark. So even, for example, you did not show your working for this and write the answer, that is correct, acceptable. But you can use the blank pages to do the working if you find this space is limited, and write the answer. So we got the moles of hydrogen now, 0.1. Now calculate the volume of hydrogen at room temperature. So after getting a moles, the formula which relate moles and volume of a gas. So mole is equals to volume of gas in dm cube divided by 24. So moles we have 0.1, and volume we don't know, divided by 24. So 24 is multiplied by 0.2, 0.1, 24 into 0.1, so it will be 2.4 decimeter cube. Now in the next question, in an experiment, 25 cm cube of sodium hydroxide of concentration 0.4 neutralized by 20 cm cube of oxalic acid. This is called oxalic acid, or also known as ethane dioic acid. The oxalic acid is a common name. Calculate the concentration of oxalic acid, but you have to follow the steps. It's not like directly you will get the concentration. You will follow the steps. The first, calculate the number of the moles in 25 cm cube 0.4 mole solution. So what is the formula which relate moles and concentration and volume of the solution? The formula which relate volume and concentration with moles. Concentration, yeah, it is moles equal concentration multiplied by volume. And that is valid for solutions. It's not valid for gases. Like if I know the volume of gas, I cannot use this formula. This is for solution, that moles equal concentration multiplied by volume. But volume should always be in dm cube. Concentration is given 0.4, but volume is in cm cube. So what I will do, I will divide by 1000 to convert into decimeter cube. What is the final answer when I solve? Means 0.4 multiplied by 0.025. 0.4 multiplied by 0.025. What's the answer? 0.01. Because it is 0.4, you can also do 0.4 multiplied by 25 divided by 1000. So 0.01. These are the moles of sodium hydroxide. Use your answer and the mole ratio from the equation. Calculate the moles of oxalic acid. So how to get the moles of oxalic acid? The ratio between them is 2:1. Sodium hydroxide 2 moles, according to equation oxalic acid 1. If we have 0.01 moles of sodium hydroxide, how many moles of oxalic acid will be there? X. Cross multiply. So it will be 0.01 divided by 2. So that will be 0.005 will be there. It's cross multiply. The simplest, the ratio between them is 2:1. 2 moles of sodium hydroxide, 1 mole of oxalic acid. 0.01 moles of sodium hydroxide, x moles of oxalic acid. Cross multiply. So 2x is equals to 0.01 or x is equals to 0.01 divided by 2. So that will be equal to 0.005 mole. Then we need a concentration. How to get a concentration? The same formula as we know, moles equal concentration into volume. So if I need concentration, concentration will be volume, moles divided by volume. So I have the moles which are 0.005 for oxalic acid, and I have the volume. What was the volume of oxalic acid? It's 20 cm cube. So it should be in dm cube divided by 1000. So 0.02. So 0.005 divided by 0.02. What's the answer? So 0.25. So the concentration is 0.25 mole per decimeter cube. Is it clear? Discussion related to the moles. Okay. In this question, we have to calculate the percentage yield. What is the meaning of the percentage yield? Percentage yield is a practical value of a product, like practically how much product we should get, divided by theoretical amount divided by multiplied by 100. That's called percentage yield. So practical value of a product, like practically how much product we should get, we are getting. Theoretically, because theoretical value, which it is always higher, the theoretical value of the product. Yeah, I'm explaining percentage yield. Percentage yield is also related to the moles. So I'm explaining the idea, what is the meaning of a percentage yield. It is also a factor which we calculate, and how we calculate the practical value of a product divided by theoretical amount of product multiplied by 100. You will get the percentage yield. So example, I will solve this question so you will understand how it is done. The same way, this is also related to moles. So it's not a new topic. In the question, 25 cm cube of sodium hydroxide, 2.24 mole per dm cube, 3.86 gram of crystals were obtained. So what is the, we are obtaining 3.86 gram of crystal, means that is the amount of the product. And that which amount is there? This is a practical amount of product, because practically what we are getting 3.86 gram of a product. So we have the practical value, like practically how much a product is obtained, that's 3.86. We have to calculate a percentage yield. So how we'll calculate a percentage yield? We'll follow the steps, and only the last formula for the percentage yield, which is a practical value of a product divided by theoretical value multiplied by 100. So we have the practical value of the product. Practically, we are obtaining 3.86 gram of a product. So you will follow the steps and you will get the answer. Now, in the question, number of moles of sodium hydroxide. How to get the moles of sodium hydroxide if we have the volume and we have the concentration? How I'll get the moles of sodium hydroxide? What will be the formula if I have the concentration?
Volume divided by 24.
Volume divided by 24 is valid for gases. If we have volume of a gas, then divide by 24.
Volume by concentration.
Volume multiplied by concentration. So volume multiplied by concentration, or concentration multiplied by volume. So volume is 25 cm cube, but it should be in dm cube. So divide by 1000 multiplied by concentration is 2.24. What's the final answer when you multiply this? 2.24 into 25 divided by 1000. 0.056. So we have 0.056 moles of sodium hydroxide. Maximum number of sodium sulfate moles that could be formed. So what is the, because about the sodium sulfate, this is a practical value. Practically we are getting this mass, but theoretically how much mass we should get? So what is the mole ratio between sodium hydroxide and sodium sulfate? What is the mole ratio between them? Sodium hydroxide to sodium sulfate. 2:1. So it means if 2 moles of sodium hydroxide are there, we should get 1 mole of sodium sulfate. So if we have 0.056 moles of sodium hydroxide, then how many moles of sodium sulfate we should get? X. Cross multiply. So it will be 0.028. So we'll get 0.028 moles of sodium sulfate. Then mass of 1 mole or molecular mass of 1 mole means molecular atomic mass is 322. Maximum yield means mass. So what is the maximum mass of sodium sulfate? So how to get the maximum mass of sodium sulfate? You have the moles and you have the mass in gram. So the formula is
Multiply.
yeah, moles. That's correct. Formula is moles equal mass in gram divided by molecular mass. But we need mass in grams, so moles multiplied by molecular mass. So moles of sodium sulfate are 0.028 and the molar mass or molecular mass is 322. It's so 0.08 multiplied by 322. What's the answer? What is the answer for sodium sulfate mass? 9.016. So 9.016, what does it mean? This is the amount of product which we should get. So this is a theoretical value. So theoretically we should get 9.016, but practically we are only getting 3.86. And there are reasons for that. Maybe the reactants are not pure. Maybe all of the product is not crystallized. Some of the left during a transferring the solution. So there are many reasons that practical values are always lower than the theoretical value. Theory suggests you should get more product, but practically when you carry out the experiment, you will get less product. So percentage yield is a practical value. So practically how much we were getting? 3.86. But theory suggests we should get 9.016 and multiply by 100. So what we will get? 3.86 divided by 9.016 into 100. So it is 42.8%. So basically what is the meaning? It means we are getting 42.8% what we should get. So the percentage yield is what is the percentage of the practical amount which we are getting compared to the theoretical value. So it's the same thing, but only the last stage when you're calculating a percentage yield, it's a practical value of a product divided by theoretical value multiplied by 100. Is it clear, this question? So first we got moles of sodium hydroxide, then we got moles of the product, and from moles of a product, we got the mass of the product. That's a theoretical mass. But practically, we are getting 3.86. Theoretically, we should get 9.016. Then into 100, we will get the percentage yield. Practical value we cannot find directly because the thing is practical values are like measurement. So measurement is done using the apparatus. So practical value you cannot find directly. Only theoretical value you can find. Practical value will be given in exam. Okay, in this question, 0.07 moles of silicon react with 25 grams of bromine. Which one is a limiting reagent? First thing, we should have both in the same unit. Like we have moles of silicon, so we should have moles of bromine. So first, how many moles of silicon are there? 0.07. How many moles of bromine are there? We don't have, but we can find. Bromine is Br2. So moles equal mass in gram, which is 25, divided by molar mass. So what will the molar mass of bromine? Atomic mass is 80, but bromine exists as Br2. So how it exists, that's called a molecular mass. So it will be 160. So 25 not divided by 80, it should be divided by 160 because how the bromine exists as Br2. So 25 divided by 160, what's the answer? that's equal to 0.16156. So use the 3 decimal places number. So 0.156, because even a small value make a difference. 0.156. That's 3 decimal places. Okay. Now we want to find the limiting reagent. So silicon and bromine, what is the ratio between them? The ratio is 1:2. So if we have 0.07 moles of silicon, how many moles of bromine should be there? X. Cross multiply. So that will be equal to 0.14. So 0.14 moles of bromine, what we need. But how many moles we have? We have 156. So we have more than what we need. So it means bromine is excess. If bromine is excess, it means the silicon is limiting. Because one is limiting means used up completely, and bromine is in excess. Because we have bromine in more than enough. Calculation in the space which is given to you. This whole part, like the way I wrote, you will also write in the same manner. These lines are given for calculation. How many moles of silicon bromide, tetrabromide are there? So we always find from limiting reagent. So what is the ratio between silicon and silicon bromide, tetrabromide? The mole ratio is 1:1. So if we have 0.07 moles of silicon, how many moles of silicon tetrabromide? Same number of moles will be there for silicon tetrabromide. Is it clear how we worked out the moles of silicon and bromine first, and then we compare using a ratio? We compare the one which we have more than enough, the moles, then that is in excess, and the other one will be a limiting. That was about empirical formula, not exactly about the moles. Just one more question, and then I will end the session. Okay, this is about basically empirical formula, like taking a simplest ratio. Simplest ratio is representing a formula. A sample of rust had the following composition: 51.85 gram iron, 22.22 gram oxygen, and 16.67 grams of water. Calculate the following and then write the formula in this for this sample of rust. Number of moles of iron. Moles equal mass in gram divided by atomic mass or molecular mass. Iron is atom. So atomic mass of iron, you can see the periodic table. Fe, it's 56. So 51.85 divided by 56. What's the answer for this? 0.926. 0.926. And number of moles of oxygen. When you're finding for empirical formula, it's better you take the 3 decimal places for a better accuracy of the final answer. So it will be 22.22. Here they're asking moles of oxygen atom. So we will divide by 16. If they say oxygen molecule, then we'll divide by 32. Because in the question they mention oxygen atom. If it was oxygen gas, even this was written oxygen only, then it means it was O2, or oxygen gas also O2. But here they specify oxygen atom, that's why 16. 22.22 divided by 16. What is the answer? 1.388. 1.389. Okay. Then number of moles of water. So water 16.67 divided by hydrogen is 1 multiplied by 2 plus oxygen is 16. So total will be 18. Yeah, 16.67 divided by 18. 0.926. Then you need a simplest ratio between them. So what is the how to take a simplest ratio? Divide by smallest value. 0.926 divided by so when I want to take a simplest ratio, I'll divide 0.926, 0.926 and 0.926. 1.389 divided by 0.926. So that's equal to 1 point. So means 1, 1.5 and 1. So whenever one of the value is 1.5, 2.5, you'll multiply all of them by 2. So basically it will be 232, the simplest ratio. To take a simplest ratio, we divide by smallest value, so 232. Now what is the formula of this rust? It contains 2 iron, because the first one is representing iron. It contains 3 oxygen and it contains 2 water molecule. So hydrated iron 3 oxide is known as rust. Is it clear, this question? So these are some questions related to moles and empirical formula. The formula, how to work out the formula of the rust? How I got the formula of the rust? You can see the simplest ratio. The simplest ratio when I worked out for iron, oxygen and water. So the simplest ratio is 2 is to 3 is to 2. So what it shows? It shows that this one contain 2 iron because 3 oxygen and contain 2 water molecule. The simple, like example, if I say the simplest ratio of magnesium and oxygen is 1 is to 1. So what is the formula of magnesium oxide? So what is the formula? The simplest ratio, we just use that. Why we did not write, you mean like this, Fe, 2Fe, 3O and 2H2? Yeah, reason for that, why? Because when we are representing the element present in a compound, look, if I say the simplest ratio of sodium and oxygen is 2 is to 1. What is the formula of the compound? I don't, what does it mean? It means it contains 2 sodium and it contains 1 oxygen. And how it contains, like how we represent a formula, we don't write a number like this. Because if I write 2Na and then O, it means this 2 is with sodium also and this 2 is with oxygen also. So when we write a formula, we write a number as a subscript. So 2 sodium are there and 1 oxygen is there. Same thing, if I write this 2, otherwise it means it is with oxygen as well. So whenever we write a formula, we use the numbers, the simplest ratio of the mole, as a subscript. Is it clear? Okay, so I'll end the session and share the recording with you.